Good day, folks. In this lesson, we're going to look at limiting and excess reactant or reagent calculations. Now, in any reactions that we're going to look at, there will be a limiting and there will be an excess. Now, let's look at the word limiting. Limiting, what is a limiting reactant? Now, it says here, a limiting reactant or reagent is a reactant that is used up completely while the other or some reactants are not used up. So is the one that is used up first is the one that is completely used up, while the other is not used up. And the one that is not used up, we call it, it's a what? It's an excess in a reaction. Let's take, for example, you are making the sandwiches. While you're making sandwiches, you have the bread, you have patty burger, and you have cheese. So your reactants are the bread, and the patty burger, and the cheese, the slices of cheese. So while you're combining them to make the sandwich, your product will be a sandwich. And as I've mentioned, what are the reactants? Now, once you run out one of the ingredients there, which is the reactant, let's say you ran out of bread first. So that means the bread is there limiting. It limits you to produce more. A product, which is the sandwich. Same applies with the reaction. In any reaction, there's a limiting. So in one of the reactant, there's a one that is going to be used up first, and the one that is not going to be used up. The one that is used up first, we call it's a limiting. The one that is not used up completely, we call it's an excess. Now, in the example that I've made, the ones that are there. Let's say the cheese is in excess. There's still more cheese. Even in the product, there's still more cheese. There's a cheese that is left out there. So we call it's an excess. Now let's look at this example. The example that I have, it says 3 moles of sulfur dioxide is mixed with 2 mole of oxygen to form the sulfur trioxide. Now we're given here are the reactants, our reactants here. So we're given 3 mole of sulfur dioxide and 2 mole of oxygen. These amounts that we are given are the amounts available. These are the amounts available. So we do not know between the two in these amounts that are available which one is going to be used up first, which one is going to be a limiting. So in these amounts, let's say in sulfur dioxide, in these 3 moles that is available, we do not know how much is needed and how much is going to be used up. Even in the oxygen, same applies. So we're going to find how much amount is needed out of these amounts. So now it says in 1.1, determine the limiting reagent. So between the two, we want to know which one is going to be used up first. So the way you do it here, you use what you call it's a mole ratio. The mole ratio, the amounts available, it needs to be moles, and your equation, it needs to be balanced there. So what are you going to do? You're going to do the ratio in those two reactants. The reactant, the limiting, it's always in the reactant. Always it will be there. So we'll do the ratio. Sulfur dioxide is to oxygen. Now, what is the ratio between the two? Is 2 is to 1. 2 is to 1. And then we'll choose that we'll check the sulfur dioxide. We'll put an X there, and then what is the amount available for oxygen? The amount available for oxygen is 2, and then we will cross multiply there. So when we cross multiply, we'll say 1 times X is X, and then 2 times 2, it's 4. It's a 4 mole. It's a 4 mole of what? It's a 4 mole of sulfur dioxide. This is the amount what? Required. This is the amount required for sulfur dioxide to react. To react with what? With a 2 mole of oxygen. So out of 3 mole that we have of oxygen, of sulfur dioxide there, the amount that is needed, it's what? It's 4 mole. So the number of mole that is required there is greater than the number of mole that is available. Remember, the number of moles that is available for sulfur dioxide, it's 3 mole, but the number of moles that is needed is what? It's 4 mole. So once we need more than what we have, therefore we call that the sulfur dioxide is a limiting reagent. So the sulfur dioxide is a limiting reagent. Why do we say that? Because this amount that we have is smaller than the amount that we need. Therefore, this amount is going to be used up. So, the sulfur dioxide is going to be used up completely. So if it's used up completely, because the amount that we needed, it was 4 mole, but we have 3. So this 3 mole needs to be used up completely. So the reaction will stop. So therefore we conclude that the sulfur dioxide is a what? Is a limiting reagent. It limits the reaction to progress. In other words, we say that the oxygen is an excess reagent. So if the sulfur dioxide is a limiting, that means the oxygen is a what? Is a an excess reagent. Now 1.2. 1.2, it says determine the amount of mass of sulfur trioxide can be formed. Now guys, now that we know which one is a limiting here, the limiting is our sulfur trioxide. So whenever we want anything in the product, we'll do the ratio of the limiting and what we need in the product. So we'll do the ratio there. We'll say sulfur dioxide, which is the limiting, is to sulfur trioxide, which is the product that we want. What is the ratio between them? Is 2:2. Once the ratio is 2:2 or 1:1, that means the number of moles will be the same. So in the sulfur dioxide, we'll use the number of moles available. We're not going to use the amount that is needed, the one that we just calculated. We'll use the amount available. So what is the amount available for the sulfur dioxide? Is 3. And then the sulfur trioxide, we needed the amount, we'll put an x there, and then we cross multiply. Once we cross multiply there, we'll say 2 times x is 2x is equal to 3 times 2, it's 6. And then we need x as a subset of the formula. We have to divide by x by 2 there, both sides. So x is going to be 3 mole. It's 3 mole of what? It's a 3 mole of what? Of sulfur trioxide. It's a 3 mole of sulfur trioxide is an amount produced when the sulfur dioxide reacts with oxygen. It will produce the 3 mole of sulfur trioxide. That's the amount that is produced. But the question, it says calculate the amount mass. So we're going to convert this number of moles into mass. So we'll use the formula that says number of moles is equal to mass over molar mass. Now we do have the number of moles that we want to convert. We want the mass, and the molar mass of the sulfur trioxide, we have to calculate it. So let's do it here aside. The molar mass of sulfur trioxide, it's going to be, the molar mass of sulfur is 32 plus the oxygen is 16. It's 16 times 3. So let's punch that in the calculator. So it's going to be 32. Let me quickly punch that in the calculator. It's 32 plus 16 times 3. It's 80. That's 8 gram per mole. So we'll insert 80 there, or we'll substitute 80 there, and then we cross multiply. The mass of sulfur trioxide, 3 times 80. 3 times 80, it's 240 grams. It's 240 gram. It's the mass of sulfur trioxide produced or formed. Now let's go to the last question. It's 1.3. Now in 1.3 it says determine the amount of mass. It's supposed to be of mass. The amount of mass of reactant that does not take part in the reaction in excess. Alright, as I've mentioned before, since the sulfur dioxide, we concluded is a limiting reagent. That means the oxygen is an excess. So we want that amount that was left in the reaction chamber of the oxygen. Remember, in this amount, in this 2 mole of oxygen, there was a small portion that was taken here, and there was an amount that was left here. Because remember, if we say it's an excess, that means this 2 mole did not react all of it. So that means there's a portion that was used to react here, and then there's a portion that remained in the reaction chamber after the reaction was complete, when the limiting reagent was used up. So we wanted that amount. So to get that amount, we must find out of this 2 how much the amount reacted out of this 2. Okay,
So it's 1.3. We'll do the mole ratio again here. So we'll do the ratio of the sulfur dioxide and the oxygen. But now we want to find the amount of oxygen, which is the limiting reagent that was used, or the amount reacted out of this 2 mole. So the ratio between the sulfur dioxide and oxygen was 2:1. 2:1, and then we'll put an X there because we want the oxygen. And what was the amount available for the sulfur dioxide? It was 3. So we want to find now the amount of oxygen reacted. So we cross multiply. So it's going to be 2x, 3 times 1, it's 3. And then we divide by 2 both sides. We divide by 2 both sides. So when we divide by 2 both sides, we'll have x is equal to 1,5 mole. This 1,5 mole, it's a 1,5 mole of what? Of oxygen. This is an amount of oxygen reacted or used. So this is the amount that reacted. But what was the amount available? So this is the amount that reacted. What is the amount available? The amount available, it was what? 2 moles. So the oxygen, it was what? 2 mole that was available there. So what are we doing now? We'll find the amount that will remain. We'll say the number of moles remain is equivalent to the number of moles available minus the number of mole reacted or used. Now, the number of moles that were available for oxygen, it was 2 mole. And then the number of moles that reacted is the one that we just calculated. So we'll minus. So out of 2, 1.5 was used. And then how much will remain? It's 0.5 mole. So this is 0.5 mole of oxygen remained or did not react. Of calculating the limiting and an excess, it says the first stage in the manufacture of nitric acid, it is illustrated by the following balance chemical equation. Right, guys, in all the chemical industries, whenever they produce anything, any chemicals that they produce, they do calculations of the amount that they need to produce. They will have the limiting and an excess in every reaction that they do in the chemical industries. Now we have our balanced equation here. We have nitric acid reacts with oxygen. It gives us the nitrogen oxide and water as a byproduct there. Now that equation is balanced, and your equation, it must be balanced. You must double check all the time that is balanced. It says suppose that equal masses of ammonia and oxygen are mixed, 750 each. So what they're saying here, we have 750 gram of this and 750 gram of oxygen there. So between the two reactants, we'll have what? A limiting and an excess between the two. So now the question, it says, remember guys, these amounts that we're given here, these are the amounts available. So we do not know in these amounts that are available how much is needed from each to react with each other. For instance, in ammonia, we do not know how much is needed from ammonia to react with oxygen. Even in oxygen, we do not know how much is needed for oxygen to react with ammonia. We're just given those amounts. So 2.1, it says determine the limiting reagent. So you can choose any to check which one is the limiting between the two. So we'll do the mole ratio between the two. We'll say the ammonia is to oxygen. Now in this case, I'm going to check the oxygen. So the ratio between the two is 4:5. And then since I'm going to check the oxygen, so I'm going to put an X in oxygen. And now here I'm supposed to put the number of moles, right? The number of moles of what? Available for ammonia. Remember this method, it's a mole ratio. So I have to first convert the ammonia into this mass of ammonia into number of moles. So I will say number of moles, because here I have to put it in number of moles. I'll say number of moles is equal to mass over molar mass. So the mass here is what? Is 750, and then we divide by the molar mass. The molar mass of ammonia, nitrogen is 14, and plus hydrogen, there are 3 hydrogens, so it will be 1 times 3 there. So it will be 750 divided by what? Divided by 17. Let's punch that in the calculator quickly. So the 750 divided by 17. So it will be 44,12 44,12 mole. So this is the amount available. So when we converted this 750, it will be what? 44,12. So here, let me erase it. So here, we'll put the 44,12 there, and then we cross multiply. So when we cross multiply, they will have 4x is equal to 5 times 44,12. So 44 times 5, so it will be 220,58, and then we divide by 4 both sides. We divide by 4. So we'll say answer divided by 4. So the answer here is 55,15 mole. This is the number of moles of what? This is the number of moles of what? Of oxygen. This is the number of moles of oxygen required. This is the amount that is required, or the amount that is going to react. So oxygen, out of this amount, it's going to need what? It's going to need 55,15. Remember, oxygen, we converted that 750 gram into number of moles. That makes what? 44,12 mole. So now, out of that 44,12, what is needed? It's 55,15. So remember, in the previous example, I said if the number of moles required, or the number of moles that is going to react, is bigger than the number of moles available. So remember, this is the number of moles, this one. It's a number of moles what? Available. This is the number of moles available. So if the number of moles that is required, or the number of moles that is going to react, is bigger, therefore we conclude that oxygen is a what? Is a limiting reactant. So if oxygen is a limiting, that means it's what? It's going to be what? Completely used up. And if oxygen is a limiting, that also means that ammonia, which is NH3, is a what? Is an excess. So that means the amount that we have for ammonia, it's not going to be used up completely. Not used up completely. So it's not going to finish that amount. So the amount that we have in oxygen, this amount is going to react to the entire amount, everything. Right? So let's go to 2.2. 2.2, it says what mass of nitrogen oxide will be produced. Guys, whenever we want, let me erase this. Whenever we want a product, anything here in the products, we use the limiting, which is our limiting is this now. We'll do the ratio of the limiting and what we're looking for. For instance, now we want the nitrogen oxide, we'll do the ratio of oxygen is to nitrogen oxide. Let's say if we wanted water, the amount of water that we'll produce, we'll do the ratio of oxygen and the water. Let's cut the chase. So 2.2, so we'll say oxygen is to what? Is to nitrogen oxide. What is the ratio between them? Is 5:4. 5:4. And what was the number of moles available for the oxygen? It was what? The oxygen, it was 44,12. Remember that 750 we converted into number of moles. So it's 44,12. And we wanted the nitrogen oxide, which is the amount that is produced. We cross multiply. So it's going to be what? 5x is equal to, so 44,12 multiplied by 4. Multiplied by 4, I punch that in the calculator, it's 176,48. And then we divide by 5. So when we divide that answer by 5, the answer will be 35,3 mole of what? Of nitrogen oxide produced. So when the ammonia reacts with an oxygen, nitrogen oxide, 35.3 mole of nitrogen oxide will be produced. Let's see if they wanted it in mass. Yes, they wanted it in mass, but we have it in number of moles. So we have to convert this into number of moles. So we'll say number of moles is equal to mass over molar mass. So converting that, we'll say the number of moles is 35,3, and we want the mass, and the molar mass of the nitrogen oxide is 14 plus 16. So what will be mass of what? Nitrogen oxide is equal to 35,3 multiplied by 14 plus 16 is what? Is the 30. So I'll multiply this by 30. So it will be the mass, it will be 1058,88 grams. It's a mass of nitrogen oxide what? Produced or formed when oxygen reacts with the ammonia.